Hello everyone. Today we will be solving AQA GCSE Chemistry May 2020 Foundation 8462 Part 3. In this video we are going to be solving from question number 8 to question number 10. This question is about structure and bonding. Which two substances have intermolecular forces between particles? So basically when we talk about intermolecular forces, we are basically talking about forces between one molecule with another. All right, for example, like a hydrogen molecule with another hydrogen molecule. So there will be intermolecular forces between these two molecules. Okay. Diamond is a giant covalent structure, so it acts like a single molecule. Magnesium is a metal has delocalized electron, so it also acts like a giant structure, so there is no molecule that will attract each other. Sodium chloride is an ionic structure, all right, where sodium ions and chloride ions are, where the sodium ions and the chloride ions are positively and negatively charged, and they form a giant lattice. All right, so they do not form molecules, so they do not have intermolecular force. Intermolecular force will exist between covalent substances, all right, and specifically smaller molecules. So water and polythene, these two molecules will be the correct answer. Table 5 shows the structure of three compounds. We can see carbon dioxide, magnesium oxide, and silicon dioxide. Compare the structure and bonding of the three compounds, carbon dioxide, magnesium oxide, and silicon dioxide. So when coming into comparison, guys, first of all, we need to understand that in carbon dioxide, we have covalent bonding, and silicon dioxide, we have covalent bonding. Okay. However, magnesium oxide is made of ions. Okay. So these are made of ions, these are made of atoms. All right. And both silicon dioxide and magnesium oxide, in this case, they are giant structures. However, carbon dioxide is a small molecule. So there will be weak intermolecular forces between one carbon dioxide molecule and another carbon dioxide molecule next to it. All of the three compounds have strong bonds, meaning that this has a strong covalent bond, there is a strong covalent bond here, and there is a strong ionic attraction here. All right, ionic bond here. So bonds, all right, between carbon dioxide and the silicon dioxide, they are covalent. However, the bonds between the magnesium oxide is, since it is formed between magnesium, which is a metal, and oxide, which is a non-metal, so they are ionic. Electrons are transferred when magnesium oxide is formed. However, silicon dioxide and carbon dioxide electrons are shared. We can see in carbon dioxide, carbon and oxygen forms carbon-oxygen double bond. All right. Whereas in silicon dioxide, we can see each silicon molecule is covalently bonded with 4 other oxygen atoms, and each oxygen atom is covalently bonded with 2 other silicon. So guys, so this is what we will write when writing. All right. I'm going to give you an example answer. Guys, some extra points. This question is about metals and the reactivity series. Which two statements are properties of most transition metals? We know that transition metals are very strong and hard metals. So they are not soft metals. They form colorless compounds. Transition metals are known to form colorful compounds. They form ions with different charges. Yes, transition metal can form ions with multiple charges. For example, iron can form Fe2 plus, iron can also form Fe3 plus. They have high melting point. Yes, transition metals have high melting point. All right, transition metals have high density, so low density is not correct. All right. A student added copper metal to colorless silver nitrate solution. The student observed pale gray crystals forming. The solution turns blue. Explain how this observation show that silver is less reactive than copper. Guys, when we see the gray crystal formation, we have to understand that actually silver is forming. The gray crystals are silver, and copper ions are basically going into the solution by displacing the silver ion. How can we tell that? Because the solution turns blue. All right. So copper is displacing silver because it is more reactive. A student is given three metals XYZ to identify. The metals are magnesium, iron, and copper. Plan an investigation to identify the three metals by comparing their reactions with dilute hydrochloric acid. Your plan should give a valid result. Okay. So guys, the procedure for this kind of reaction will be, we will add the dilute hydrochloric acid to the metals. All right. And then what we're going to do is we're going to measure the temperature change. Because they have different reactivity, they will produce different amount of exothermic reaction. But to make sure that we are doing a proper experiment, we have to add the same amount of dilute hydrochloric acid in every cases. Okay. So what can we do for this process? We can measure the temperature change. All right. And then, all right, for copper, there will be no reaction because we know that copper does not react with dilute hydrochloric acid. So it will show no temperature change. All right. For magnesium and iron, magnesium will increase in temperature more than iron. All right. And for iron, we're going to have less amount of, temperature change. However, the volume and the concentration of hydrochloric acid must be same. And the number of moles of metal used in every experiment should be the same in order to keep the experiment fair. I'll give you an example answer. Metal M has two isotopes. Table 6 shows the mass number and percentage abundance of the isotopes. You can see 203, 30, 205, 70. Calculate the relative atomic mass AR of the metal M. To calculate the relative atomic mass, we will have to multiply the first mass number with its percentage abundance. And then we will have to multiply the second mass number with its percentage abundance. Since both of the percentage abundance is in percentage, so we'll have to divide it by 100. So the answer will be 204.4. Because our answer is required up until 1 decimal place. This question is about silver iodide. Silver iodide is produced in the reaction between silver nitrate solution and silver iodide solution. So silver iodide and sodium iodide. Silver nitrate and sodium iodide is reacted together to produce silver iodide and sodium nitrate. Okay, great. A student investigated the law of conservation of mass. Pour silver nitrate solution into beaker labeled A. So the student is pouring it in a beaker labeled A. Okay. All right. Pour sodium iodide solution into beaker labeled B. So in a different beaker, we have sodium iodide and we have silver nitrate in this beaker. Okay. Measure the masses of both beakers and their contents. Okay. Pour the solution from beaker B into beaker A. Okay. So beaker B into beaker A, meaning that we're mixing it together. Measure the masses of both beakers and their contents again. Okay. So basically after we have put A plus B together in here. Okay. Alright, measure the masses of the both beakers and their contents again. Beaker A contains 78.26, beaker B contains 78.50. After mixing in grams, 108.22, 48.54. Okay. So explain how the results demonstrate the law of conservation of mass. You should use data from the table 7 in your answer. Okay, since we are pouring beaker B content into beaker A, so beaker B mass has decreased. Okay, whatever mass has decreased is increased on beaker A. So all right, and the reaction also took place. So total mass before, so we'll add 78.26 plus 78.50 equals to 156.76. Okay, and then total mass after. (108.22) plus 48.54. Again, this is equals to 156.76. This means the mass of the product is equal to the mass of the reactants. Suggest how the student could separate the insoluble silver iodide from a mixture at the end of the reaction. Okay, so because it already says that this is insoluble silver iodide, so a simple filtration technique will separate it out. So filtration using filter paper. The student purified the separated silver iodide. This is the method used. So rinse the silver iodide with distilled water. Okay, very good. This removes any surface impurities. And warm the silver iodide. Okay, suggest one impurity that was removed by rinsing with water. So basically what happened was, when we added the silver nitrate with sodium iodide, we got silver iodide, which is AgI, and also we were left with sodium nitrate. That sodium nitrate was in the solution, that didn't precipitate out, and that will be as a contamination with the silver iodide powder. So the impurity will be sodium nitrate. Suggest why the student warmed the silver iodide. Okay, the student warmed the silver iodide definitely to dry it up. Okay, so to evaporate water. Calculate the percentage atom economy for the production of silver iodide in this reaction. Okay, so we have silver nitrate reacting with sodium iodide, producing silver iodide and sodium nitrate. Relative formula mass 170, 150, and silver iodide 235 and sodium nitrate 85. All of them are given. Okay, great. So we want to find out atom economy. Now, in order to find out atom economy, the general formula of it will be mass of desired product which will be divided by, all right, mass of desired product will be divided by mass of total reactant. And then we'll multiply this by 100 to get it into percentage. This is the percentage, however, we'll have to give it up to 3 significant figure. So the answer will be 73.4%. Give one reason why the reactions with high atom economy are used in industry. So basically, atoms with, reactions with high atom economy are good for the environment because it produces less amount of wastages. Okay, all right. So it's very economical. Guys, that's all for today's video. All right. For those who have exam, best of luck for your exam, guys. Guys, videos like this will be uploaded every day. And if you like the video and you like the channel, then definitely subscribe. All right. Let your friends know about the channel and let this channel grow. All right. I will be uploading all the chemistry, biology, and physics related question paper from all the, particularly UK boards. All right. I'll also include AP and IB, all right, in future. So subscribe and stay with the channel and let the channel grow. Thank you for watching the video. See you in the next video. Bye bye.